Good afternoon to everyone. In the last session, I posted the pre-recorded the videos, linear search and binary search. Hope you would have gone through that. Now, let's focus on how to implement the searching strategies, linear search and binary search in a C language. Take this code. Write a C program. Check. Write a C program to check if the given searching element is given a searching element is available given list or the type of searching that we are going to apply is into the linear search, or what is other name of linear search?
Sequential search.
Yes, very good. That is a sequential search. In this, we have the list of inputs. The inputs are stored in the one-dimensional array. For example, A is a one-dimensional array which consists of n elements. A1, A2, A3, etc. An. And one searching element is retrieved. The searching element is X. The problem is checking if the given searching element X is available in the array or not. In case if it is available, we need to find the index where the searching element is available. If not, we need to display or we need to give the message. The searching element is not available in the array. This is the problem, linear search or sequential search. We can implement the searching process by comparing the searching element with the array element. As we have seen, we can compare the process from left to right or from right to left. First, the searching element X is compared with the first location in the array. In case if there is a successful match, we need to terminate the process by skipping the subsequent successful searches if any. Now we can continue right until the end of the list. In case the searching element is not available in the array, first location not available, not in the first location in the array, then we need to increment the index and check for the next index. So this way we need to continue the search, right, until reaching the last location in the list or array. At any stage when X is not equal to A1, A2, A3, etc., An, finally we need to conclude that the searching element is not available in the array. This is the linear or the sequential search problem. To implement this, we have to include header file. I have to include stdio.h. Then writing the main function in A. What is required? We need to define the array. For example, int A of 50. Then the searching element is X. and n, which represents the number of elements of the number of input elements. Having this a declaration, let us have the printf statements. Printf slash n. Please enter the value of n. N is obtained through a scanf statement. Scanf percentage d ampersand. Then we need to enter n inputs. These n inputs are going to be stored in a one-dimensional array. Our array name is A. So have another printf statement. Printf slash n. Please enter percentage d inputs. What is percentage d? N. Please enter n inputs. N inputs. Find this through the scanf statement. Scanf percentage d should be enclosed right within a path conveniently. Have a variable, for example, j. For j starts at 0, j is equal to 0, j less than n, j plus plus. That means the range of variable j is 0 to n minus 1. Here, assuming that the array index values are right from 0 to n minus 1, we have a for loop that starts at 0. For j is equal to 0, j less than n, j plus plus. What is our conditional test to be made here? Not if, right? Let us first get the input values and then the searching element to j. J is equal to 0, j less than n, j plus plus. Have a scanf statement. Scanf percentage d ampersand. What is the array name? Array name is A of j. So that the far ranges from 0 to n minus 1. When j is equal to 0, the first input is assigned to A of 0. When j is equal to n minus 1, the last input is assigned to A of n minus 1 location in the value. Then we need another input value. That input is a searching element. So first have a printf statement. Printf slash n. Please enter the searching element. Searching element is stored in a variable x, for example. So write the scanf statement, scanf percentage d ampersand x. The inputs are clearly obtained in the variables. One in x, the searching element. Another one is n values, which are stored in the complete array B. So starting index is 0, last index is n minus 1, such that the value of x should be less than or equal to 15. In case if you like to input right more inputs, you need to increase the array size. For example, int a of 2. After this, we need to check if the given searching element x is available in the array. For that, we can pass these values to a function so that the function checks if the searching element x is available in the array. So first, here let us write a function, then we come back to the main function to complete the function call and process the result. For example, here the function is linear search, linear underscore search or linear search. What are the inputs required? The inputs are array elements and one searching element. If you like, you can define the array elements as a global array and the searching element X may also be declared as a global one. Otherwise, here, if I like to use same thing array here, I use int A array and int X. These are formal parameters to the function call. The formal parameters.
Sir,
Yes,
uh, sir, in the code, sir, I have a small doubt, sir.
what is the doubt?
Sir, in the code we put array has 50 spaces, no, sir, 50 size array.
Yes,
And we asked how much space we wanted to input. Yes, sir, to in the second line, enter the values.
yeah, there, right, your input should be right restricted to right a maximum of 50. Please enter percentage in the inputs. Here you can restrict right less than or equal to 50.
Okay, sir.
Into a reasonable message. Later you see right how to allocate the memory right dynamically. So sort now right assuming that the array size is 50, we are asked to enter the maximum of 50 elements. In case if you like to have more array size, try to increase the array size here manually. Then give a reasonable right a printf message so that the user will be able to give the maximum size. Okay.
Okay, sir. Clear, sir.
Okay. Now coming to the function definition. First, understand int is a return type. Linear search. This is the name of the function. Here we have two formal parameters. One is the int a array. So when you have a formal parameters like this array of formal parameters, do not specify the size. So int a array, please understand, right? I left the dimension. Do not specify the dimension. Then int x. What is int x? X is the searching element. Now, if you want, right, you can specify another one, int n, which represents the number of elements in the array, that is size of the array. So having these formal parameters, just think of A is the array available in the linear search function. We can implement a linear search process here. For example, using the for loop, for int, I use a variable say j, int j is equal to 0, j less than n, j plus plus. What is our comparison process? We need to check if the searching element is available in the array. Searching element is x. If x is equal to array element, jth element in the index. If x is equal to a of g, then what is the meaning? The searching element is available at jth location in the array. Since j starts at 0, we can return a value. What on j plus 1. So if x is equal to a of g, we can return a value, return, for example, j plus 1. Else, we need to continue the process until the last element is going to be compared. That is, x is equal to a of n minus 1. Why we put j plus 1 means we assumed the array index started at 0. Suppose 1, 2, 3 is our input. 1 is the searching element. 1 is available at the first location in the array. So when j is equal to 0, 1 is equal to a of 0 condition is true. So So we return the value, right? 0 plus 1, 1. In case if there is a failure search, after making all these comparisons, x is equal to a of j over the range of j is equal to 0 to n minus 1, control comes out of a for loop. So when the control comes out of the for loop, we have checked x with all the array elements. So when x is not equal to a of j for j is equal to 0 to n minus 1, then only control will come out of for loop. At that stage, searching element is not available in the array. For example, I return a value minus 1. Minus 1, this is the indication of unsuccessful search. Return j plus 1, this is the indication of successful search. We are finding the first successful search. So once you find the first occurrence of the searching element, we are returning that index. Index is exactly j plus 1. We are not bothering about the second, third, fourth, etc. successful searches, if any. In case if you like to print second, third, fourth, etc. successful searches, instead of return j plus 1, we need to print the message in the function definition itself. For example, the searching element is available at the jth location in the array. Here I assume that only the first occurrence, first successful occurrence is enough. So here, after checking if x is equal to a of j, I am returning a value j plus 1. Since the return type is int 1, here the returned value should be processed in the function call statement. Carefully understand, in the function call, we are passing more elements in terms of array. So when you pass an array as a parameter, as the actual parameter to a function, please specify the name of the array. Name of the array is A. That is enough. Do not specify anything there. A of 50, A of 2. You put A of 50, only one element, the 50th element is false. If you put A of 2, the second element is false. Mention the array name. What happens? The complete array is passed as a parameter to the function definition. So that in the formal parameter, do not specify the array size. We check everything. Simply define the receiving side parameter, formal parameter like this. Data type array name, write empty bracket. X and N are a for our purpose, right? The searching element. For example, I use same X. I can pass same N. X and N, right? Available in RA, X and N available in the main function are local variables to main. Again, A, X and N available in the function definition are local to the function definition. In case if you want to skip all the parameters, A, array, X and N, please make all this as a global declarations, global variables, global arrays and global variables, so that you can simply call a linear search without any actual parameter, simply linear search of empty parameter list. Since the return value is being assigned, right? Here, for example, I use the variable index, another one. Index, right? Another variable is defined here. So index is equal to linear search a comma x comma n. Can you tell me what are the possible values of index will assign, or what are the possible values of linear search, which is going to, or the function is going to be returned? Possible values of function return values.
So possible values are 0, 1, 2, and so on. Sir.
Yeah, 0, 1, 2, etc. N minus 1, because maximum value of j is n minus 1. 0, 1, 2, etc. N minus 1. 0, is it possible? No. 0, right? 0 is returned as 0 plus 1, 1. So possible values are 1, 2, 3, etc. Here, the indices. Other than that, in case of unsuccessful search, minus 1 will be returned. So possible values are minus 1, comma 1, comma 2, comma 3, comma etc. Here. These are the only values to be returned from the function. So that the returned value is further being assigned in the left-hand side variable index. Here what we have to do, we need to check the value of index. If the index is minus 1, you need to tell the given element is not available in the array. In case if you make this as return type as void, to try to print everything in the function definition. Here I use to return a value. So I am checking first if index is equal to minus 1. If the index is equal to minus 1, print out searching element, right? I use percentage is not available in the given list or given array. Percentage is x. X is not available in the given list. Else, print out searching element, right? We mean, for example, 5 is at third location. Percentage is at location. Percentage is available. Percentage is available at location. Percentage is comma. First one is x. Second one, location is given as index. Then let us complete the main function section. Say return g. This is the user defined function section. Now let us have the function prototype. What is the function prototype? In linear approach. First parameter is, have a look into the formal parameter used into A array. So you need type as it is in A array. Then second and the third parameters are integer ones. So we can make integer x, comma integer n. Let us check the code. File name, file I think CP72. File save CP72. Let us compile the code F9. Fine, no compile time errors are reported. We have typed the code correctly. Then let us check the code. Control F9. Enter the value of n. Suppose n is 3. Enter 5 inputs. Enter the value of 5 inputs. Actually, that message should be given here. Enter the value of n. Then we should give this message. Shift delete. Enter the value of n. Shift insert. Then we should use message. Input size should be less than or equal to 50. Control F9. Enter the value of n. N should be less than or equal to 50. Suppose array size is 5. 5 inputs I do like to do 10, 20, 5, 12, 27. We can give the inputs in any order. This need not be in the sorted order. That is important. 10, 25, 12, and 27. Press enter. Enter the searching element. Suppose I give the searching element as 5. Now what happens? We are expecting the message. The third location, right, have the quantity, right, 5. So 5 is available at location S3. Likewise, we need to check for boundary conditions also. Enter the number of inputs 1, 3 inputs 1, 2, 0. Enter the searching element of 0. 0 is available at location S3. Control F9. N is say 3 inputs 0, 1, 2. Input is 0. 0 is available at location 1. Control F9 for unsuccessful search. Enter 2 inputs 10 minus 10. I do like to check it. 50 is percent. P is not available in the given list. So this is the implementation of a linear search. In this implementation, you can see this is the normal form. We made the comparison from left to right. Since array index starts at 0, we have compared the array elements with the searching element in left to right direction. That is, x is equal to a of j, where j ranges from 0 to n minus 1. In case if you want to reverse the for loop comparison, we can start j at n minus 1. J should be greater than or equal to 0. J minus minus. So in the reverse order, you will be making the comparison. That is one thing. So this highlighted code, this is simply the forward comparison of array elements with the searching element. That logic has been implemented here. In case if there is a successful search, only one time x is equal to a of j becomes true. That means that will be the first time. We are not comparing the subsequent successful searches with any, because we have the function concept. Function returns maximum one value to the calling phase. So when return j plus 1 is executed, that's all. Control will never come back to execute the next iteration of j. So only one successful search is obtained and the value is returned to the main function. In case when the searching element is not available in the array, that return minus 1 returns the value to the calling phase where we process it. If the index is equal to minus 1, we have entered the message. The searching element is not available in the given list. So this is for both successful and unsuccessful searches. First, have any doubts in this linear search implementation? Last class we have gone through that video. The same thing that has been implemented here in C language. I used the concept of function. First, understand this logic. Have any doubts?
No doubt, sir.
Okay. Another thing in the same program, you might have noticed that actual parameter is completely array of elements. That is very important. So now let us come back to actual formal parameter and function prototype statement. Carefully note here, A is an array. When A is an array, actual parameter takes the name of the array. Name of the array is A. Do not specify A bracket, empty bracket. If specify A empty bracket, compiler reports the expression syntax in function main. That means it assumes that you have missed some index in between these opening and closing brackets. So, in what way compiler is assuming here? It assumes that you are missing one index value to pass one element to the corresponding formal parameter. In case if you write a of 0, what happens? Logically, right? Only one element, that is a of 0 alone, passed to the formal parameter. But here, the formal parameter is completely an array, right? Here we cannot pass a single element to be assigned to the array. So miss the dimension along with the brackets. So I recompile again. A empty bracket. This results in expression syntax in function me. So what is the only solution when you have array of inputs which are passed as actual parameters to the function? Simply specify the name of the array. In our case, A is just the name of the array. So only name of the array is passed as a parameter. Do not specify anything, size, empty bracket, everything will not be accepted when passing array of values. Only specify the array name as the parameter. Then x and n, right? These are our case. We have to process the searching element and the number of elements. So for our case, right, since these inputs are being obtained right through the main function, since the computation will be taken place in the separate function, conveniently we are passing the inputs x and n. X is one integer input searching element, and n is another integer input that defines the total number of elements in the array. So in the same order, x and n, previously array elements are being received in the formal parameters. So first note it, when you pass the entire array as actual parameter, please mention only the name of the array. That is the way to pass the entire array of values to a function. Another thing that we have to note here, if I write simply into A, it will save time. This results in a compile time error because this results in the invalid declaration. Actual parameter is array name. So array of inputs are passed to the formal parameter. Then A takes multiple values in the actual parameter. Multiple values cannot be received in the single A as in the formal parameter. That's what your compiler reports a error message. So we remember actual parameter is an array. What about the formal parameter? The formal parameter here also do not specify size in this. We specify the size like now what happens? Enter family of n2, 2 inputs, 1, 2, searching element is 2, or 2 is available at the second location. So here it takes 50 memory locations in the local array. Anyhow, here we have declared right 50 memory locations. And since we are completely passing the entire array elements to the function definition, it like right try to specify the size. Otherwise, just leave it as we have done earlier in the A array. This is enough. So that whatever is the actual parameter size with respect to the array, that many number of memory locations will be created here. So we can leave the size right empty. Otherwise, specify the size exactly. This is the thing to be noted in the formal parameter list. Then coming to the function prototype. First one is the array name. So if you specify, for example, normal variable GPG, this results in compile time error because actual formal parameters are arrays. First parameter here it should be the array. If you specify the array size, say into A of 50, it's accepted, but right not necessarily right to specify the array size exactly. Simply specify empty bracket. Another thing to be noted is let me comment on this declaration and write in another way. Link linear search. How can you write the parameter list or sorry, how can you make the function prototype here in another way? By omitting the variables list. Function prototype and need not involve the variables list. What is expected in the function prototype?
Data types, Rasani.
Yes, only data types are enough. So here we have right as 1, 2, 3, right? Three data types, right? For the variables a, x, and y. You would have noticed right earlier. Suppose int a means we can use int. Then for x and again we can use int comma int comma int. Data type is enough. In this case, what is a? A is the array of inputs, array of integers. So when A is array of integers, if you simply mention one int, what happens? This will not hold array of elements. So again, compiler reports the error message. To avoid that, carefully check actual formal parameters, array of inputs. So if you just ignore variable name a, here how we have done x is removed, n is removed. Simply we put x comma x. Simply we put int comma int. The same way, if you remove right the array name a and type int empty bracket, in this case, what happens? One empty bracket. So this assumes that the function is defined right following the main function that it takes three parameters. First parameter int empty bracket that signifies the compiler. First one is array of integer values or integer array of values. Size is not necessary. Size is not actually right taken from the actual to formal parameters. So int empty bracket, this is enough by ignoring the actual variable names. Of course, array name is the subscripted variable name. Arrays are subscripted variables. So names are ignored here, A, X, and N. Simply specify the types int, int, int. But first one is array of integers. So int, then specify this empty brackets. Now let us check, enter the value of n, say 5. 5 into 1, 2, 3, 4, 5. Searching element -1. -1 is not available in the given list. You can continuously type, right? Continuously type int with empty brackets. Int space empty brackets. Both are accepted. And the space control F9. Input is 1, 1 input 100. Searching element is 100. 100 is available at first location in the array. So please note these things when we pass array to a function. What about actual parameter? Actual parameter is simply the name of the array. What about the formal parameter? Formal parameter should be defined with respect to the data type. Data type, array name. Then two possibilities, you can put empty brackets or empty brackets align the size of the formal parameter. With respect to the function prototype, declaration state, follow the normal approach, data type, variable name 1, data type, variable name 2, etc. Otherwise, variables are simply ignored. We can specify the data types with arrays defined using this empty brackets declaration. This is the logic of a linear search implementation. Here we have implemented with respect to the function. Function returns a value to the calling fields. In case if you want to make this is a global declaration. For example, I save the file saves CP73. In this case, to make everything as a global declaration, here you need to define in the A output. X is a searching element and represent the size of the input array. So here I remove these variables int j comma index. This is a global variable. These are global variables A, X, N. The global variables. What about the actual parameter here? What needs to be processed? Empty, because variables A, that is array of inputs, array X and N, are available completely within the program. So no need to pass any actual parameter. Actual parameter is empty. Then there is no change here. What about the formal parameter? This also empty. Okay. Here are the variables X, E, N. These are accessible. The local variable J alone needs to be defined as into J is equal to 0. Because of a global variables concept, arrays X, N, these are accessible both in main function as well as user defined function. What is the error message? Too few parameters in call. How do we rectify this error message? Respect to its function prototype. Since the function does not take any parameters. Prototype you need to make this is every parameter list. So here leave the parameters to simply F9 control F9 enter the value of n. Suppose 6 enter 6 inputs. Enter the searching element. Say minus 200 is available at the sixth location in the array. So whatever is your choice, you can define a function so that you can, if you want, you can pass the array of elements as the parameters to the function. Otherwise, make everything as the global variables. Get inputs inside the main function. The global array searching element number of values n are being easily accessible in the user-defined function here, so that you can find the comparison process from left to right direction. In case if you like to find the successive occurrences, first, second, third, fourth, etc., you need to modify the code. For example, I try to save the file as CP74 here to find out the subsequent occurrences. Here I write x is equal to a of c. You need to give a message. Print up percentage d is at the location percentage d. First percentage d x. Second one at location j plus 1. In this case, you can return value j or j plus 1 here, but logically, since we do like to find the multiple successful searches, so better to make the return type as void one. So I try to change this is void in the function prototype. This will be it is void linear search. If x is equal to a of j, x is at location j plus 1. Return j, this will be removed. Delete. This is actually for a successful search. So when j is equal to 0, right? After checking this one, then it checks again j is equal to 1, then j is equal to 2. So to stay continuous until reaching the end of the array or till reaching the last location in the array. Finally, you need to tell the searching element is not available. Write printf slash n percentage is not available. X. What happens? It gives the message. In case if it is available, it prints a message. Some X is at location, some X. After the completion of part, unexpectedly, right, we have a message. X is not available. For example, Fine. What is the error message? Return value, right? I think simply for a linear search. Ignore these lines. These are processed in the function definition itself. Suppose 1, 2, 3, 4. Suppose the element is 2. And then I say 2 is at location 2. Then 2 is not available. Because j is checked for the range 0 to n minus 1. After checking all these, right, successfully, right, the message is printed. But after this part, unexpectedly, right, you have the message percentage d is not available. Or consider these inputs and control F9. Suppose 4 inputs 1, 1, 2, 1. In this case, searching element is say 1. 1 is at location 1. Then that is a continuation, right? I missed slash n, or I put here slash n here. So F9. Just 4 inputs 1, 1, say 2, 1. And see the message searching element is 1. 1 is at location 1. Then 1 is at location 2. Then 1 is at location 4. Finally, you can see the unexpected message 1 is not available. In case n is 4, a 4 inputs 1, 1, 2, 1. Searching element is 4. 4 is not available. So this case it's okay. But here 1, 1, 2, 1, 1. Finally, we have the unexpected message 1 is not available. So what is the logic to rectify that?
Sir,
Media? Yes.
we can introduce a small variable like m, sir.
Okay.
So every time this printf comes, we can say m equals m plus 1.
Okay.
And then finally we can, after the for loop, we can write an if condition. If m equal to 0, then only we'll print not available.
Good. So at any stage, right, if x is equal to a of c, as you said, right, you can increment one variable. When the condition fails for all values of g, that means when x is not equal to any of the values in this set, or x is not equal to, right, okay, a of 0, a of 1, etc., a of n minus 1. In this stage, only we need to give the message the searching element is not available. So as I said, right here, introduce one variable and initialize, right, before part initialize the value of that variable, say some f is equal to 0. For example, here, okay, count r to c is equal to 0. If x is equal to a of g, as you said here, before or after printf, increment the count by 1, say the c plus plus. Finally, this will be checked using the if statement. If c is 0, printf percentage it is not available. We try to run program by giving the same inputs. Four inputs, 1, 1, 1. searching element is 1. 1 is at location 1, 2, and 2. Here, right, we didn't have or receive the message. 1 is not available. In case for unsuccessful search, it is 5. 5 inputs 1, 2, 3, 4, 5. Enter the searching element 6. 6 is not available. So this is the logic, right, to find the multiple successful occurrences. If or this message, right, a printer can be given right before the for or after the before the for, right? Uh, Locations, successful locations. If you give the message, right, printer slash and percentage days at locations, then here simply put a value 6 plus 1, percentage it is 8 plus 1. So when we find some successful locations, that will get printed, otherwise n is at r, 5 is at location. In case of unsuccessful search rate, you will not get anything, right? Blank. Finally, you will get a message, percentage it is not available. So this is the version, right, to find out the multiple successful searches. Have any doubts?
No doubt, sir.
Then using right arrays, right, one-dimensional arrays, right, and functions. You try to write solve these exercises. I give two exercises. One, find the maximum in the array of elements. Return the result to the main function. We have to do, you need to define a user-defined function. In that function, right, you can have some array of elements. You can have a local array and get inputs, find the maximum, and the result should be returned to the following this main function. Next one, find the number of positive numbers or positive integers given array. Return the result to the main function. And find a local array or a global array or even inside the main function, you can define the array. Get input values. These values are passed to the function parameters. Inside the function definition, find a count on, find the number of positive integers. That means find the count on the number of positive integers. Find the count on the number of positive integers given array. This will be implemented inside the function definition and return the result. You like to return, let's say, 4 positive integers. We are given 10 integers. Out of 10, for example, 4 positive integers, 5 positive integers are actually calculated inside the function definition. So that count, say 4, 5, 0 are going to be returned to the main function, and inside the main function print the relevant message. The given array consists of 5 positive integers. The given array consists of no positive integers. Likewise, we need to have the reasonable range of messages inside the main function. Hope you understand. Passing arrays to the function. Use of one-dimensional arrays. Have any doubts?
No doubt, sir. Clear, sir.
Okay, please go through this session. In the next session, we focus on multi-dimensional arrays. Specifically, we focus on a two-dimensional array, and let us solve the problems based on the two-dimensional arrays. Okay, thank you very much.
Thank you, sir.
Thank you, sir.